All right, today we're diving into a concept that is truly, truly mind-bending, pulled straight from a scientific registry file. It's a theoretical technology called APED, and it asks a radical question. What if we could actually program matter to just fall apart? I mean, cleanly, with precision, and totally on command. It's an idea that could change, well, pretty much everything. So let's get into how this whole thing is supposed to work.
So to really wrap your head around APED, you've got to start with this huge mental flip. See, in quantum physics, decoherence is normally the enemy. It's this messy, uncontrolled collapse where a fragile quantum state just gives up and becomes part of our regular world, usually wrecking the whole experiment. It's seen as a total failure. But the view behind APED, it takes that very same failure and says, what if that's not a bug? What if that's a precision engine for taking things apart? And that right there is the entire game. It's all about reframing a fundamental limitation. It's about taking something that was always considered a problem in the quantum world and turning it into the central, most important feature of an unbelievably powerful new tool. Okay, let's bring this down to earth for a second. Think about the gnarliest pollutants we have, plastics that stick around for thousands of years, or just complex toxic waste. What if you could just point something at them, flip a switch, and have them deconstruct themselves into their original, harmless building blocks? I mean, that's the ultimate prize here. And this incredible technology has a name that just perfectly sums up what it does. APED. It stands for a process of directed substrate deconstruction. And the key word there is directed. See, the idea is we're not just smashing things apart, we are carefully guiding them to unmake themselves. Now, the full name, Adaptive Path-Dependent Entanglement Decay, is a mouthful, I know, but it actually tells you exactly what's going on. It's a system that adapts to a material's unique history, that's its path dependence, and then it uses a controlled quantum collapse, the entanglement decay, to release energy with surgical precision. At the end of the day, it's a controlled collapse for a very specific targeted result. The process itself is envisioned as this super clean three-step dance. First, you target your material, let's say it's a really stubborn pollutant. Second, you activate the process by applying a catalyst. And third, you just watch as it deconstructs, breaking all the way down to its base molecules. And here's the critical part, with zero toxic byproducts. Okay, so how does this so-called quantum demolition crew actually get the job done? What are the tools in its toolkit? This is where things get really, really cool. So the system has two core parts. First, you've got these things called MQPCs. The easiest way to think of them is like tiny preloaded demolition charges. They're basically biopolymers that store entangled quantum energy right where you need it. Then you have the DAC. That's the trigger. It's a very specific laser pulse that zaps those charges and says, okay, time to collapse, releasing all that stored energy with incredible focus. This quote from the source file just nails the mechanism perfectly. This is not a sledgehammer approach. The laser pulse is resonant. It's tuned to a perfect frequency. And the collapse it triggers releases just enough energy to snip a specific molecular bond with the same kind of precision as a biological enzyme. It's like quantum surgery, not a chemical bomb. So where on earth did an idea like this even come from? Well, the inspiration for APD is just fascinating because it comes from three completely different, totally diverse fields. You've got fungi, the physics of light, and, get this, urban planning. First up, you've got mycology, the science of fungi. Fungi are nature's absolute masters of decomposition. They don't just randomly rot stuff. They release very specific enzymes to break down complex materials on the outside. APED totally borrows that idea, an external agent designed for targeted deconstruction. Next, you have quantum optics. This is the engine room of the whole operation. This is the science that gives us the power to create and control those incredibly delicate, isolated quantum states. That's the entangled energy that's just sitting there waiting for the laser pulse. It literally provides the quantum in our quantum demolition crew. And here is the real wild card. Urban planning. Yeah, you heard me right. This field brings in the concept of path dependence. It's the idea that a city's history, the way its streets were first laid out, constrains how it can grow in the future. APED applies that same logic to molecules. A material's own history, how it was made, actually creates specific pathways and limits for how it can be unmade. Now, this is where it gets really deep. Beyond the incredible science, the source material suggests something even more profound. It argues that a technology like APED would force us to completely redefine how we even think about things like decay and entropy. And this slide really shows that philosophical shift. We're all taught to think of entropy as this messy, one-way street to chaos and disorder. But in the world of APED, decay can actually be a form of adaptive coherence. It's not just things falling apart randomly. It's a structured, functional, and even useful process of returning to a simpler state. One of the authors, who goes by Lucien Delta, puts it so beautifully here. Decoherence isn't destruction, it's redistribution. It's a moment when information is gently returned to the universe as tender heat. It completely reframes a destructive act into a moment of release. And this all leads to the central metaphor they use, the physics of forgiveness. Every single controlled collapse isn't a failure, it's a renewal. It's a chance for matter to be unmade so its building blocks can be used again. It's just such a powerful and poetic way to think about a physical process. But okay, let's get our feet back on the ground. This is all highly, highly theoretical, and the authors are totally aware of the massive challenges that stand between this idea and it becoming a reality. So let's look at the hurdles they've already thought about. They've mapped out 3 huge issues. First, the cost of placing all these quantum dots would be astronomical, so the proposed solution is something called mycolithography, basically engineering microbes to do the delicate assembly work for us. Then there are some really fundamental thermodynamic limits, which they think they can get around by treating the whole process as a super-fast, fleeting event. And finally, the most serious one, the risk of this being weaponized. Their proposed solution? Build in tuning locks so the tech can only ever work on specific regulated materials. So let's just boil this all down. What are the big things to remember about this incredible concept? First, APED takes a quantum flaw and makes it a precision tool. It gets there by mashing up ideas from fungi, physics, and even urban planning. It forces us to look at decay not as chaos, but as a kind of ordered process. And at the end of the day, it's a potential blueprint for unmaking matter with absolute purpose. The document ends with this. They call it a closing invocation, and it's just too good not to share. It points to this future where we could learn to control deconstruction with the same care we use for construction. Finding this perfect balance between order and freedom, between making and unmaking. And that really just leaves us with this one final, massive question to chew on. For basically all of human history, we've focused on building things to last forever. But if we actually master the art of unmaking, if we can truly engineer decay, does that completely change what permanence even means? What does it really mean to build something that lasts?